Hi students, so here we meet again in another video. So in the previous video I couldn't teach you as to how you can generate the scatter diagram. To practice as to how to generate a scatter diagram, we are going to practice the two given questions in your lecture slides. So you know what is meant by scatter diagram. We have discussed previously also what is meant by scatter diagrams. In scatter diagram, what we really do is that you are going to graphically illustrate as to what kind of a relationship is existing in between two variables. So if we look at this particular example, read the example given. So here it says PC were provided rating for 50 notebooks PCs. The performance score is a measure of how fast a PC can run a mix of common business applications as compared to a baseline machine. For example, a PC with a performance score of 200 is twice as fast as the baseline machine. A 100-point scale was used to provide an overall rating for each notebook testing in the study. A score in the 90s is exceptional, while one in the 70s is above average. Dataset PCs shows the performance scores and the overall ratings of the 15 notebooks. So here, to download the particular dataset, go to CourseWeb. In the CourseWeb, I have uploaded the particular dataset as PC. So first of all, download the particular dataset. So once after you have downloaded the particular data set, you can see what was exactly mentioned in the given description. In the first question, first exercise, what is exactly described is, you can see here, look at here. So here you have the performance score and the overall rating. So based on the performance score, the overall rating is going to get differed. So that simply means that performance score becomes your X variable or the independent variable, and overall rating becomes your dependent variable. And so what is the first question? Part A, you are asked to visually represent the relationship between two variables using a scatter diagram. So when you are asked to represent the relationship in between two variables visually, you should know what is the tool that you have to use. So if you are asked to represent the relationship between two variables visually, you would be using scatter diagram. So for this particular data set, you have to show, for this particular data set, you have to graphically visualize as to what sort of a relationship is there. So to graphically illustrate as to what sort of a relationship is there, you have to first select the data set. There is a easy method. So you have to select the data set, go to insert, and here you have the scatter option. So insert scatter diagram. So this would be your scatter diagram, but there are some missing things here. You don't have the axis labels here, and you don't have the correct title over here. So here I would be typing the title as scatter diagram for performance score and overall rating. And we need to have the axis labels as well. To add the axis labels, here choose the plus mark and choose axis titles. So here on this axis title, this is y axis where we have the overall rating, and in this you have here you have the X independent variable as performance score. Okay, clear? So based on this particular scatter diagram, we can see that the plots are situated closely to each other, but however, when we look at the data set and the y variable over here we can see the y variable is overall rating, but we don't see any zeros here. So rather than starting from 0, it's good for you to start from a number like 50, because here the minimum number would be, we can see by looking at the data set, the minimum is 67. So if we start from 50, it would be more appropriate. So in order to start the particular y-axis from 50, you have to go to this particular line and click on left. So you have to click left in your mouse and go to format axis. So in format axis you have the minimum number as 0, but we need it as 50. So when we go for 50, it automatically gets changed. Now the numbers are starting from 50, which is more appropriate. So same as that, when it comes to x-axis also, here x-axis has been starting from somewhere around 115, where it is more closer to 100 rather than starting from 0. It would be more appropriate for you to start from 100. So we'll change it. Right click, so go to the horizontal axis and right click, go to format axis. So here we would be starting from 100. Okay, so here also, by looking at the graphical illustration or the scatter diagram, what sort of a relationship do you all see? So here most of the plots are situated closely to each other. That simply means that, sorry, I have missed a particular letter here. Okay, so by looking at the scatter diagram, you all can see that there is since the plots are situated closely to each other, we say that there seems to be a strong positive relationship. The reason why we are saying it's positive is because there is a gradient towards this side. When x has been increasing, y has also been increasing. So we say there's a positive, and the reason why we are saying there is a strong relationship is because this most of the plots are situated closely to each other. Okay, and I hope it's recording. Okay, and now, so for one person, I might be saying there is a positive strong relationship. Another student, maybe Supipi might say that there seems to be a moderate positive relationship in between the two variables considered. But since we want to be exact as to what sort of a relationship is there, we are going to calculate the correlation coefficient, which we have been discussing in the previous video. So how can you calculate the correlation coefficient? In order to calculate the correlation coefficient, I have taught you two particular methods. One is by using the formula. So what is the formula? It's CORREL. So once you type COR, you get the particular formula suggested as CORREL. Tab it. So what is the first array? So, sorry. Here we have to give me a minute. So here, so many outside sounds are coming. I'm sorry. I hope you can concentrate on what I am saying. So CORREL, tab it. First array is this performance score, and put a comma, and the second array is overall rating. We are going to consider the arrays without the labels when it comes to formula. So here you are getting a correlation coefficient of 0.779. That simply means that I was right. So it means that just as you see in the scatter diagram, there is a strong positive relationship in between performance score and overall rating. So what is the other way that you can use in order to generate the correlation coefficient? So by using the data analysis tool pack, go to data. If you have enabled the data analysis tool pack, which is not readily available in Microsoft Excel, so you have to make it available by using add-in. So if once after you have made it available, it would be available under data tab. So in the data analysis tool pack, go to data analysis and go to correlation. So here in the correlation, you have to put the input range. So here, when it comes to data analysis tool pack, once after you have put in the input range, you have to select both the x data values and the y data values, and it is grouped by columns. So we have performance score and overall rating in separate columns. So since I have not selected the labels in the first row, so when I was selecting the input range, I have not selected the labels. So I don't have to tick off this, so I'll leave it as it is, and I'm going to take the output in the same worksheet here. Now click OK. So here, look at here. So here and here we are getting the same value, same correlation coefficient. So I'll show you another one. So once after you have gone to here, and suppose when you're selecting input range, I'm selecting performance score like this. So that means I have selected the labels also. So choose labels in first row, and now I'm going to take the output somewhere over here. Okay, so when we take the output like that with the labels, when you select the input range with the labels, you would be getting the particular variable name in the output. Okay, so here the in between overall rating and performance score there is a correlation coefficient of 0.779, which simply means that what does that figure means, what does it interpret? So it interprets that there is a strong positive relationship in between the overall rating and the performance score. So just like this, you can try the other exercise. So here the part C is that what does the sample correlation coefficient tell about the relationship between performance score and the overall rating. So it simply means that in between performance score and the overall rating there is a strong positive correlation. So just like that, you can download the particular data set for exercise 2. Here in the exercise 2 it's about the Dow Jones Industrial Average and the Standard Poor's Index. So you can download the particular data set from CourseWeb. This is the particular data set. Download it and try doing it on your own. So if you have any questions, please feel free to comment in the forum given. I would be always there to help you. Okay, thank you so much. So that's it about the correlation coefficient. Thank you.